confirm. Welcome to Grafana head-wearing tempo call. Today is the 8th of April, 2021, and the topic is how Joe Elliott's beard has reached terminal length, and he cannot grow any more beard than he currently has. Over to you.
There was a discussion earlier. I was trying to figure out how to get more distance on this beard. I have never been able to get past this. I'd like a little bit more, but if anybody has any suggestions, feel free to drop it in Slack. I feel like that should be the content of this call. But to talk about tempo a little bit, if we wanted to do that, we do have the doc here. I've left the agenda blank. I like to give people an opportunity to put what they want in and to kind of address anything maybe the community has first. But if there's no, if there's no, if there's no immediate things anybody has, we have plenty kind of to discuss on our side. So I'll pause for a bit, and if you have anything, you're welcome to just bring it up verbally, unmute, or you can type it into the doc under the agenda section. And hello to the new people.
If you have a hat, be quick and bring one.
Yeah, I'm looking around and I cannot find any hat.
Okay. Well, I'll get going here and do some stuff. Like I said, this is pretty open, so you're welcome to either just unmute yourself and talk, or if you want to put something in the doc to be discussed, we can cover anything kind of related to tempo or hats or beard growing, apparently. I think the first thing to discuss was some work that Ananya did earlier this week, which was push our tempo cluster to 1 million spans per second, which was kind of a goal for maybe the last call or two. We've been talking about hitting this. And so he kind of did some adjustments. We had this kind of like downsampled version of our write path, and I think we're up to like 30 or 40% of that, which is what pushed us over the million spans per second barrier. And frankly, it's been kind of a non-event. Everything's just working. It's kind of disappointing. Sometimes you want things to break a little bit to see why, and learn something new about your system. But yeah, it's just kind of merrily chugging along. Let me post like a guy in here, a graph. So if you, we're like in the upper 900,000s. If you rate it over a minute, you could break 1 million. Like, watch this. All right, here we go. Boom.
You're not actually screen sharing, so we don't see anything.
I was gonna post here. Oh, my bad. I could screen share. There's our technically 1 million spans per second in the doc. We for a brief moment crossed the threshold. I mean, it would be simple to just bump it by a few more percent and be like solidly over 1 million. It's just whatever. We haven't done it. But things are easy at 1 million spans per second. It's been, like I said, kind of a non-event. Our write path and read path are looking very scalable. We've basically kind of spent maybe the last month with just kind of the different performance improvements it would take to get here. And yeah, it's just working, which is a good thing. Kind of other metrics here are, let's see what I looked at last. We are at 15 billion traces in our backend. So we have 14-day retention. And really, this particular change has only been on for maybe 3 days now. So this will actually grow. I don't expect there to be major problems as it grows, but it will. We're at 15 billion traces, and then 30 terabytes of compressed trace data that we're searching when we look up a trace. Our current, I'll put some latency metrics in here. Should I screen share? Should I just do that?
Up to you. I think it's good to see on the doc.
And if you have anything secret, but we can also just blur if something secret is. But that is then on you and not on me, because I don't want to do this work anymore. But screen sharing is better than not screen sharing. Also, FYI, I screen shared the doc with the Spike just earlier.
Okay, that's a good idea. Let me screen share the doc. That way I can't screw up too poorly. and I'll just post things in the doc. So yeah, I think our P50, P90s are pretty good. I think our latencies. P99 is kind of like just below 2.5 seconds, which I'm happy with. Honestly, we have found the majority of our time is spent basically, let's see, present now, Boop. A window, hopefully the correct one, doink. We've really found that our biggest problem with our biggest latency, the biggest thing that contributes to latency is recombining traces. So we often have a trace stored in multiple locations, perhaps multiple blocks, or even in different places in the ingester, like at kind of different stages as we move it through and eventually flush it. And it costs a lot in terms of marshaling that to proto, iterating through, and basically rebuilding the trace, making sure every span is there, and making a new one. There's perhaps a future of Tempo that doesn't rely on proto, and maybe we have a custom format or a flat buffer style format or something that maybe parses faster and is less memory intensive than protobuf. But that's where we are now. And like I said, I'm very happy with this. The spikes tend to be just larger traces. So when we have a 5-second query or a 10-second query, it's because somebody queried a 50 meg trace or something enormous and not something, you know, in the hundreds or thousands of spans.
I have a question, like all those benchmarks with the spans, you know, spans can have different number of metadata inside. Is there any kind of number of metadata you are aiming for those spans? Or because it can be one span with, you know, 2 label values, label pairs, let's say, and millions label pairs.
That's a good point. When we started this kind of work, I was really focused on spans per second and kind of like traces per second as metrics and as kind of limits as well. We've actually been spending a lot of time swapping everything over to bytes limits and bytes per second, all these things. So actually the current limits on our Tempo cloud offering are in spans, but are about to be switched to bytes. So yeah, that's a great point. Our average is, I think, about 150 bytes per span. And that has a huge range. Some spans are just literally the span name. Some are, you know, chock full of logs and events and tags, and can be, you know, maybe even a K or more, or several K. And we've actually seen similar kind of ranges on our, you know, on our public offering as well. Kind of some people average a K plus per span, and some people average even less than we do. To share bytes per second, that's not a poor idea. Let me go here. I think I just looked at this, and we're at like 100 and something megs per second.
No, this is a great job. Like, I really love that.
We're at 110 megs per second.
Thanks. Who said that? Oh, Nanya. Hey! He's here and he has a hat.
It took me 5 minutes to find it.
And so, yeah, there's megabytes per second. That is, you know, 90s megabytes per second, not whatever decade we're in now, megabytes per second. I still can't get used to the megabytes versus megabytes thing. When I say megabytes, I mean 1024 is their base.
Yeah. And what about, you know, it looks like we are kind of getting into this level of 1 million spans per second, but is there any like scalability limit to go further, or is like, you know, can we just horizontally scale something?
The limits we feel like are mainly in the compactor at the moment. So this is about 5,000 blocks worth of data that we're searching, and that's kind of like, you know, a constraint on your query path and kind of the compactor. The bottleneck is like just getting data out of GCS, recombining it, and putting it back in GCS. Our write path is horizontally scalable quite a bit. I mean, it's all based on the Cortex/Loki kind of architecture that will not break for a long time. Our query path is also horizontally scalable. We kind of can shard basically a query into a number of jobs, and we do 25 right now. So when the query starts broken into 25 pieces, and each query just does that tiny piece. And so obviously at some point, if you're at some point you're going to break something when you say 100 pieces or 1,000 pieces, right? It's just going to start failing. Some of those queries are going to fail. You're going to fail your return. So I think I would say we're comfortable in the millions of spans per second. Maybe around 10 to 20 million is where maybe some things would break. We'd have to kind of reconsider. Ananya is actually doing some work right now on our Bloom filters, which will severely reduce the number of blocks we have to check, which will be just another thing that will help us, push into the tens of millions. And then it just also comes down to like, how much is Grafana willing to spend on its internal ops cluster? Because, at some point, is it really worth it to us to ingest 10 million spans per second? Maybe as an experiment, but like all the time? No, probably not.
Makes sense. Thank you. I'm pretty sure there are like good learnings for Cortex and Thanos and those systems, Loki, that we can inherit. Like the Bloom filters, I think something we want to add on those systems as well.
Sure.
So yeah, good stuff.
Cool. Thanks.
And by the way, just I think it escalated, but we're doing Promcom demo with some kind of Prometheus stuff and some other stuff. And it was so easy to just add tempo, like a one, kind of binary thing, and just directly consume pushes from application and like show exemplars. So that's super neat to kind of set it up.
Very cool. Yeah, I saw your PR, I guess, was it Argos or something? But yeah, I appreciate that. That was neat to see you working with that.
Yeah, I had problem, to be honest, to find a good YAMLs, because I'm not really using that much JSONnet, and even if I use JSONnet, I have to use Tanka to see your example manifest, and it was blocking for me. I had to essentially just craft my own deployment, and then I used Golang to directly see configuration, so that part was easy. But maybe there is something to do on the documentation side to just give me example YAMLs, just generate that for me, just keep it, right? And don't rely on someone using Helm or JSONnet or Tanka. Yeah, but this is a small thing. Yeah.
Okay. Now that's a good point. There are quite a few. If you look in the repo under example, and we should do a better job of documenting this. In fact, that's kind of a goal for kind of a 1.0 release. But if you look under GitHub example / Docker Compose, there's like 6 or 7 examples in there with different backends, including like single binary options. So hopefully that would kind of might cover your needs. But
I seen those, and there are no YAML manifest. I'm pretty sure. Can we double check?
Manifests even under those,
Yes.
right? I think we should just dump our manifest.
Just dump whatever JSONnet and Tanka generate.
Yeah.
That's easier. Just on
Okay.
this position.
okay, I'll make a note. Thanks.
That's another improvement we made from the last release, I guess. Like now, previously we needed the tempo query container, and now it's like a true real binary, single binary. Sorry, and it's like we just need the tempo binary that connects to Grafana. I don't know if that was discussed already, but yeah, that's like a cool new thing.
No, but that's a good thing to come into next, actually. I was definitely wanting to get into that. So Ananya, do you want to talk about, there's kind of, right now we have this kind of tension between Grafana 7.5 and the current state of tempo. Do you want to talk about that as well as how it applies to tempo query?
Sure. So yeah, the latest release of Grafana 7.5.x, like all the minor patch releases after 7.5, connect to the tempo query frontend or like the tempo single binary if you're running it in single binary directly. And they do not need this specific tempo query container, which was actually Jaeger query with the gRPC plugin and HashiCorp Go plugin. And so, but we do not yet have a release of tempo that's compatible with that. And so it basically works off of master. Like you can use, so I think a good thing to do would be to link a hash of an image that actually works with the latest Grafana. I can add that to the doc. But yeah, just something to keep in mind. If you're upgrading Grafana from 7.4 to 5, that workflow will break because we're no longer connecting to that tempo query container. And yeah, that's about it. Yeah, I was just going to say I'm going to add the image hash to this document. And then we can yeah, just use that one.
Right, it is kind of a bad spot. We will try to cut 070 as soon as possible. We're just kind of working on a couple things internally before we can get that done. But as soon as we can, we'll get 070 out, and then kind of tempo latest will work with Grafana latest. And then, yeah, kind of excited to drop tempo query. It was just kind of an annoying thing to always have, and it's nice to have one less dependency, one less thing to have to figure out. And I know it was blocking for, I think, people who are using OpenShift didn't quite work right in OpenShift, and there's some other issues surrounding it. So good to move past it.
It's also a performance gain because there's one, to and fro from proto, like in-memory object that we're saving, because like we're no longer marshalling at the tempo query. So that's also good.
Yep. Cool. Why don't we talk a bit about some of the agent work? So Mario is a newer team member. He was here last month, but he's done some really exciting things in the agent, improving kind of what we can get out of it and its interaction with Grafana Cloud. So Mario, do you want to show some of what you're doing there? And I will stop.
Yeah,
presenting.
sure. I've prepared a very simple live demo. Let's see how that works. Demos.
It will work.
Don't worry.
flawlessly.
We expect incidents and failures.
We'll just blame Joe. It's completely fine.
I don't know how can.
That's acceptable. You're welcome.
No,
Completely.
no.
I'm not finding my tab.
Well, this is starting off well.
Yeah. All right. Okay. Well, I'll talk about first of what we've been working on. So we recently merged like a first pass of generating metrics from spans. It's at the moment it's a very simple implementation. We're just processing all these spans and exposing a Prometheus exporter in the very same agent. In order to those metrics to get exported to Cortex, like any other integration with the agent, at the moment, the agent has to scrape itself. But yeah, we're looking into how we can directly hook those metrics to basically make it a simpler solution. So you don't have to specify, okay, scrape this Prometheus exporter that is running in an arbitrary port, because in the end, it's a bit of a toil to configure and operate. If you have 10 tempo instances inside the same agent, you have to configure 10 scrape configs. And the other thing that we've been working on, it's been tail-based sampling. I haven't opened the PR yet. That's more complex, a bit more complex feature. So the biggest challenge right now is that in order to do sampling for a trace, we have to have all these pans for a trace in the same agent. And we can run the agent in different modes. And if in those modes, like you can run multiple agent instances, and spans for a same trace could arrive to different agents. So basically, we have to load balance the spans between the agents. Once that is resolved, we just can apply tail-based sampling. At the moment, we can only do a very basic tail sampling. It's a processor from Open Telemetry. Yeah, and I'll see now if I can share my screen. Like the issue is I cannot find my other Google Chrome. I only see this one.
So you should have write a %null thing, and when you click it, you should get a choice between complete desktop or window or a Chrome tab. Do you see the thing in the lower right?
Yeah.
Okay. And then
Well, I don't know which. I have a couple of Grafana tabs. Let's see which one is it.
Cross
Is
your
this
fingers.
one?
you can just close everything else, then you know which it is.
All right. Yeah, I think
looks
it's
good.
this one.
Yeah.
Okay. Awesome. So the setup is that I have 3 agents running. Actually, I'm only sending traces to one of them, to agent timer 1. But for example, it works. Like you can see right here that only one agent is receiving traces, but then metrics appear for all 3 agents. And also from the span metrics, I'm extracting the URL for the traces. And the tail sampling that I want to do now is just select one of the flows of this synthetic generator and see how the others, like the URLs that don't belong to that flow, just disappear. So I'm resetting the agents with the new config now.
It's cool.
Yep. That looks super great. Yeah, amazing.
And yeah, so soon enough, well, thanks. We'll see that a couple of these URLs just disappear. They're not on the flow, they get basically dropped. So like if the trace does not contain this URL, it gets dropped. So yeah, we can wait a few seconds or just move on to another thing or answer
Cool.
a couple of questions.
Yeah, I have a question. Is that metric just calls?
Yeah, I mean,
Can you
yeah,
control that at all? Can you? That's
yeah,
a really bad
you
metric
can
name.
namespace it.
Okay.
But by default, it doesn't have a namespace at the moment. So yeah, not very descriptive.
Okay. You could at least put a prefix of some kind on it.
Yeah.
Okay.
Definitely.
Now that's a counter, so I think it should be underscore total. Is that is underscore Richie is the perfect person to answer this. Is underscore total is that a standard in open metrics or convention in open metrics?
It's actually required. It marks it.
Okay.
And it's things are actually enforced if you speak open metrics, like the client libraries and such. They put it on the end of the counter if you forget it.
Okay. So we should work at PRing that upstream to OpenTelemetry to improve this metric to be correctly named, to be calls total for sure.
Yeah.
Cool.
All right. Now we can see that a few of the metrics have been dropped because we are now tail sampling by the URL.
Cool.
So works on local, works in that machine.
Right.
But still, there are a lot of still challenges ahead. I mean, obviously, even if I open this PR, load balancing the spans across the agents is going to be tricky. Depending on the setup, maybe agents can't find themselves that easily. Maybe they need authentication, and then it's going to just cause an overhead that is not going to be trivial. And also for tail sampling, like you have to collect the entire trace, and traces can be very big or span across huge amounts of time. So like in the end, you have to buffer for a given time or give up on that trace. Yeah, and tuning that also can be like really tricky. If your P100 of trace duration, it's, I don't know, 1 minute, buffering 1 minute of traces, it's a lot of memory.
Cool. To talk a little bit about OpenTelemetry also, so the agent, at least just the tracing portion of the agent, is based on the collector. And we would like to, of course, continue to work with them and PR any improvements we make upstream. But we also kind of know we'll be kind of experimenting with things in the agent they won't want to take, and also there'll just be some Grafana specific things. So generally our stance will be to kind of work with them and give as much of the work we do, upstream with the OpenTelemetry repos. But if they won't take it or whatever, it's just too Grafana-y, then it'll just kind of live in the agent only. If you do use the agent and you are, using some of these processors, or you even see an OpenTelemetry processor that you would like in the agent, please, open an issue on the Grafana agent repo. It's generally actually not very difficult to get a new processor into the pipeline. So feel free to request that on the agent repo, and we can get that for you, or more like Mario can get that for you. And so that's I'll put the link in the doc, but it should be this. I'm kind of typing it from memory, but I believe it's that. Cool. Let's see. What else are we doing today? So we did the scale. We talked about some of this agent stuff we're interested in. Ananya is getting into this new bloom filter change. Do you want to talk about that at all? What time is it? Oh, it's at 1. We have half an hour. Yeah. Do you want to get into this, Ananya?
Sure. So yeah, so recently we scaled up to 1 million spans per second. That was pretty cool. And now we're looking at the next big thing, which is obviously 10 million. Right? And to get there, a lot of the parts, most of Tempo will just work as it is. It'll scale to 10 million. There are a few things that we're worried about. As we scale to 10 million, the number of blocks is going to grow by a large factor. And to keep that in check, we're going to have to compact more and more. We're going to start having to make super large blocks. And these super large blocks are going to have super large bloom filters. At 600,000 spans per second, we were seeing 10 MBs of blooms, and sharded over 10, we would see 1 MB, and our max size for an object in cache is 5 MB, and we'd be spending 15 gigs on memcache, and we don't want to be we want to have more control over how much space we can allot to memcache. And so what we're really trying to do is trying to impose some limits on how large the bloom filters can grow to. And so we just don't want them to grow to 20, 30 MBs. We want to say, hey, for each of my blocks, I want to have bloom filters that have 10 shards, and each of those are 1 MB each. Even if my false positive rates for the bloom filters are going to go down. Which way are they going to go? The false positives would go up, right? Okay, for the smaller blocks, the bloom filters will be more accurate, and for the larger ones, they'll be less accurate, whichever way that means false positives will go. So yeah, and so for that, we want to make this bloom filter sharding configurable. We want to have more control over the size, basically. And so I'm working towards that. And yeah, that's about it.
Cool. I posted something in the doc here. It's barely readable. I had to make it tiny and fight with it a bit. But 28% of our blocks are these tiniest blocks that we've just flushed. So the ingesters are making a new block every 3 seconds or so. And each block is about 2 gigs, uncompressed, and looks like about 3. Well, how is that? Oh, largest size, about 300 megs. So they're between 200 and 300 megs each. Every 3 seconds, we push a block that size. And so what Ananya is doing is basically reconfiguring things to be more dynamic. So we have much more aggressive false positive rates against our small blocks. So we check them way less. And our large blocks have basically they're more lenient, and we're going to check those large blocks much more often, but the large blocks are a smaller percentage, basically, of our total sizes. So we think we can basically make more efficient bloom filters using this idea, and it will allow us to scale. We found as we scaled higher and higher, this level 0 blocks list grows bigger and bigger because we're just making more faster and faster, essentially. And it's the hardest thing to deal with. So at 5 million spans per second, the total level 0 blocks might be half of all of our blocks, maybe, because they haven't had a chance to be compacted yet. And this will prevent us from having to search all those all the time, essentially, which is awesome.
What's the cost in CPU and RAM and storage for those 1 million per second?
CPU cost? We're at about, you want to like know how many cores we're spending doing this? Yeah. We are at about 200 cores on Google Cloud. About 300 gigs of memory. We're ingesting 110 megasecond. Oh, we looked at that already. And our total storage in GCS is about 30 to 40 terabytes right now of compressed trace data.
So comparing to the 300K, which we talked about, I think 3 months ago, that is, we had 50 cores, something 80 gig of RAM and 80 terabytes of storage. So more than triple of CPU and RAM, but half of object storage. Does this sound roughly correct?
Right. So we added compression, which is why our storage dropped, just tanked basically. When we're storing way more. What else did we do? Oh, we went from a replication factor of 2, which is a really weird replication factor to work with, but I really liked it, so I kind of pushed it maybe farther than I should have, up to replication. Yeah, Nanya's smiling. He knows I did. So we went to replication factor 3, which is much more standard, way easier to work with, way more like just way more research done on it. It makes more sense. Everybody says 3, and then you have a write quorum of 2 and a read quorum of 2. It just works way better. I still like 2. And if I wasn't providing this as a service that people paid for, I'd probably do 2. If I was doing this internally, I'd either do 2 or 1 because it'd be way cheaper. And I think it would meet the needs of the company way better. But since we're selling this as a service, we want to do 3. 3 has strong guarantees about read and write, and always returning what you've written after you query it. And that's why we've probably seen a increase in CPU and memory for that reason. Oops, I got this backwards. 300 meg and about 200 CPU. And I've got this under Bloom filter improvements, which is absolutely incorrect. I'll move this up to, oh, my bad. Let's do this, right? Current. There you go. Cool. I think I had one more item, if no one has any questions.
Megabyte of RAM? And
I'm
Eric,
sorry?
you can start talking. No, just...
I had one question. If you could maybe talk a little bit philosophically about the sampling goals for Tempo, because as far as I understand, Tempo is kind of different from the other solutions in that you're talking about like you can sample everything and you can get to all of those traces through logs, which is fantastic. But then from the other side of the picture, from metrics and exemplars, you can only get to a very small subset of them because of your scrape interval and the time series constraints that you have. So I was wondering if there's some interplay there with sampling.
Yeah, so we are primarily at Grafana, we use basically per endpoint sampling. So it's a feature of basically the Jaeger clients because we started on Jaeger, and it's also supported by the collector as well, the OpenTemplate collector and the Grafana agent. But basically, every endpoint is sampled independently. So our read endpoints, which are the ones who are most interested, are 100% sampled. Our write endpoints, I think, are at 30 or 40% sampled, which are far more boring. So we're also experimenting with I guess maybe I should take a step back. I think there's like a couple of strategies here. There's like a flat down sample strategy, right? Like I'm going to just take 30% of everything or 15% of everything, 100% of everything. There's the per operation strategy, which we really like at Grafana and have used very effectively. And then there's the tail-based strategy, which we're just getting into. And we are exploring with Mario's work and trying to see how we feel about that. The tail-based strategy is, of course, kind of focused on making more intelligent decisions at like a lot of CPU and memory cost to buffer these things up and to like go through every span and make some choices. So whenever I'm talking about sampling with people, it's always just kind of like, it's just kind of a value choice, right? What do you really want to see? What is the most important thing to see? And how much are you willing to pay to have that, nobody cares. Well, I don't think anybody cares if their health endpoints are traced, right? But some people are pushing us health endpoint traces, right? It's a single span that says, oh, somebody accessed your health endpoint. So kind of finding a strategy that works is really dependent on every kind of org, team, application almost sometimes. And you kind of have to take a step back and see the tools that you have. Can you use the per endpoint sampling? Are you using it at your clients or can you not? Do you have the kind of tech ability or buy-in to set up tail-based sampling, which is kind of a heavier lift than just flat down sampling? So everything comes with like a cost, basically.
Yeah, that makes sense. I guess the kind of thing I'm kind of looking for is whether the error path is kind of the one that is more important when you're committing to things like SLOs, and those things are things you typically look for in exemplars, but that's the thing that you can only sample so much of.
Right. So the way that kind of works here is because our read path is 100% sampled, we know every single dashboard that is showing a query, every exemplar is going to work, and every log line is going to work, every link. Whereas like the dashboards that are showing us latencies or error rates on our write path, yeah, we kind of have that issue where you're like clicking a few before maybe you find one that you like or is in your backend. So that still kind of exists for us on the write path. We could 100% sample everything, but like I said, it's not worth the cost to us. It's the same choice everyone's making, right? Like how much are we going to pay to store all this data? And so we're sampling what we really want. And we're in early days with tail-based sampling through this OTel stuff, and we might find we really like that pattern as well. Maybe I've kind of thought maybe our write path is tail-based sampled, and we only get these errors or these super latent queries or super latent writes, and our read path is 100% sampled still, and we kind of keep that pattern there. So that's a potential future for Grafana tracing that I see, but Mario's still kind of digging into that and getting us set up with that.
Okay, thank you very much.
Sure. Cool. Somebody else should have taken notes, man. I didn't write down any of that. That's good stuff too. Let's see.
That's recorded.
Yeah, we can go for the recording.
That's right. Check recording.
Check recording.
I guess the final thing I have, and after this is done, we can open it up. If anybody has any kind of questions or whatever, you're welcome to jump in and ask, or just any kind of conversation topic you're wanting to pursue is fine. We had a community issue that kind of brought up a few things related to S3. It was kind of put on the forum. That's one thing I want to talk about. Is if you are having issues, the forum's a great place to get answers. It doesn't get a lot of traffic right now, but I check daily. And if you have a question, it's a great place to add it where we can kind of like keep history and post configs. And it's a little bit better than Slack for kind of like longer running conversations. Slack is great for just kind of like poking for a quick answer, and sometimes that's fine. But if it's kind of a longer running conversation, I'm going to push you to this community forum because that way it can be searchable in the future, and other people can kind of gain value out of the work that we do to triage your issue. But this particular issue, somebody's seeing unhealthy compactors, which we have seen, and I wanted to point out if you are seeing this, please kind of get involved in this conversation. But member list is having this issue. This is a member list issue, particularly on larger clusters, where basically we don't know what happens, but ingesters or compactors or distributors stay unhealthy in the ring. Stay in the ring. You're kind of like clicking this forget button, it's not working, and you're kind of frustrated with this thing. And this guy is seeing this issue, it seems like, on S3, and he's seeing it so severely that it's actually preventing querying his backend. He's making so many blocks, and he has all these partial blocks. So I wanted to just kind of make people aware of this issue. We do use memberless to maintain our rings. Also, that is just the default. Both console and etcd work as well. We're re-vendoring the Cortex libraries, which support console and etcd. So if you prefer that path, please use it. And I just wanted to bring awareness, because if you are seeing this, please comment and share your experience, because AWS is actually also seeing this with Cortex, because they run Cortex on memberless in AWS. And so they're also kind of tracking this issue on the Cortex side, and any information we can get about this will help us kind of continue to improve memberless and improve this. I'd kind of like to stay on memberless because I just don't have to run one less thing. But you know, I'm not really sure where we're going to go with this. I've also posted our config here. This is the config we've landed on that is the most stable. We have the least issues with this. We still kind of have these unhealthy compactor issues occasionally. But this has been the one that has grown the farthest and had the least issues kind of as we've grown. So if you are running Tempo, if you're seeing any of this, like I said, please, you know, put your 2 cents in, let us know what you're seeing. And also feel free to grab this config and maybe try it out. If you're having issues, it might smooth things over for you. Also, if you're on S3, we don't run it on S3, which is frustrating at times. I've kind of considered just starting up an AWS S3 cluster just to make sure that there's no issues there, because it's hard for us to see those. And this person is having issues, and I am not 100% confident in my answers sometimes, or my ability to triage it, because I'm not seeing, you know, exactly what this person is saying. So if you are running on S3 and not having issues, it'd be good to hear, or you are having similar issues, please, please let us know so we can track those down and get those solved.
I'm on S3 and no issue so far.
Okay, very cool. Thanks, Zach.
But I'm on first Tempo cluster.
Sure. Cool. If you do see things as you scale up, I've seen you kind of active in the Slack. Please let us know, you know, what you're seeing. And if you're having some kind of like configuration or querying issues, please pass it on.
While we're on memberlist, and I got a little bit of a bashing, I just want to sing some phrases for memberlist. We actually did a cluster migration internally recently, and in which we literally had to migrate from a routes-based GK cluster to a VPC-based one. And the trick that we used there was actually to spin up ingesters in the new cluster that use memberlist to connect to the old one. And it just worked perfectly. Like we had components in 2 clusters on the same ring, and we didn't actually see a lot of issues. It worked perfectly. We shut down ingesters in the old cluster. Slowly, the write traffic moved over to the new one. And yeah, well, I mean, there's a blog post that I'm writing, and that should be out in a couple of weeks, I hope. But yeah, just want to say that memberlist worked really well. I didn't actually think that it would be smooth, but yeah, it's pretty cool.
Nice. Well, if anybody has anything else, any questions or comments, or just, yeah, if you just want to chat about whatever the weather's like in your part of the world, yeah, feel free to.
It's windy in here.
It's windy? It's what... It's nice outside today. I'm going to go to bike ride, maybe right after this, I'm not sure.
I have a small question.
Sure.
Are there any particular parts of like the Open Telemetry resource SDKs or the semantic conventions that that Tempo in particular are picking up on?
We do use the. That's a good question. I think some of what Mario showed plays into that a little bit, because some of those metrics are based on some of the semantic conventions and the tag names. Mario, do you want to talk about that?
Yeah, sure. I mean, it basically is a processor from Open Telemetry, so it's by default picking up the convention from on-build telemetry, like the basic tags or spans. Yeah, I don't remember which one is the name in each code base. So yeah, and also the structure of fetching more spans more tags out of the spans. Again, it follows all the open telemetry convention. So basically, there is no other way than following that, at least in some regard.
I guess the reason for my question, because I saw service.name has like a very specific way it's being handled on the interface. Yeah. I don't know if there's any, but that also seems to be a Jaeger convention. So I don't know if there's any other special things like that. But I guess it sounds like it's not.
I don't know. I don't think so. But maybe I haven't toyed enough with the processor. I also noticed that by default, it just picks up span types, like whether you like it or not. So.
I do know that we do some keying off of, there's the status code on a span, and you can set that to error. Can't remember the value. I think it's 1. There's 0, 1, 2 or something. So I do know we have a little bit of functionality based around that. But for the most part, we take OpenTelemetry Proto, store it, and give it straight back to you. So there's not a lot of tempo built around OpenTelemetry specific things. We just consume it and hand it right back. Okay. But yeah, some of what Mario's getting into with those metrics are kind of built around the tag conventions and such. And I think we'll learn about that more as we build it out. Cool, thank you. All right. Well, thank you all for showing up. And thank you all for wearing funny hats and less funny hats. Hope you all take care, and we'll see you hopefully next month. Keep us up to date. Jump in Slack. Jump on the community forums. File issues in the repo. We'd be glad to engage you kind of however you all want to be. Just jump in and let us know what you're doing. See you all later.
If you want, also. Now I did the thing where I break the complete saying goodbye thing. Yeah.
I'm here for you, Richie.
I was about to say that I'm tempted to play with a format where people can just literally show how they did something with Tempo and the other projects during the calls. But anyone who's watching the video, and if you're interested in kind of give us a holler or just join the thing. And look into the description of the video. Of course, I started putting the video in, the link to the doc into the video description.
Okay.
Thanks, Richie.
Yeah.
Yeah.
All right. Take care.